Alright, so hello students, welcome you all once again to this YouTube channel. In this video, I'm back with yet another mind-blowing shortcut trick to calculate the activation energy problems. See, many students will feel difficulty to solve the problems from activation energy, and many of them will leave the problems whenever they're asked from this topic. But wait, don't leave the problem. I am going to teach you a super cool trick in this video so that you can solve this type of problems with more accuracy and more sooner, faster than the other students who solve these problems with the regular method. Regular method is also good, but I'll be teaching you a shortcut method. Alright. See, first let's read the question. For a reaction taking place in 3 steps, we are having 3 steps, and the rate constant they have given us K1, K2 and K3, and the overall rate constant is, see, this is the most important thing we have to grasp. K they have given us K1, K2 by K3 they have given us. If the energy of activation value for first, second and third are 40, 50 and 60 kilojoules, the overall energy of the activation in kilojoule per mole, we have to find the overall energy of activation, and they have given K1, K2 and K3 in kilojoule per mole. Now, how to approach this problem? We have a separate formula for energy of activation calculation, A, E, all those things we can do, but we need to calculate this with the help of a shortcut trick. Listen to me what I am doing. Now what we need, overall activation energy. This is activation, okay, just in shortcut form I'm just writing it, okay. Overall activation energy, EA. Alright, now what we have to do is, first K1, K2 and K3. K1 and K2 are the in numerator, and we can see they are being multiplied, but K3 is in denominator. So how we have to do is, first K1's EA, K1's activation energy and K2's activation energy we have to add, okay, because they both are in the numerator. Now K3 is in denominator, so what we have to do is just subtract K3's activation energy. That's all. What is K1 activation energy? 40 plus this is 50 and this one is 60. They have given already, right? 40, 50 and 60. K1, K2 and K3's activation energy. Now 40 plus 50 is 90. 90 minus 60 is 30 kilojoule per mole. Am I right? So in 2 steps. How many steps? In just 2 steps you got your answer. So simple, right? See, many students will go on solving this with the regular method. Regular method is also good, but you yourself tell me which method is fast and accurate, this method or that method. Of course this method, right? It's very soon you can solve this big problem just in 2 steps with this method. Alright, so this is very cool method, you can use this. Now let's take one more example. See, another example I am taking here, you can read. See, they have given a reaction take place in 3 steps with individual reactions some they have given, and the main thing what you have to focus, what I told you, right? This one, what they have given, this K is equal to overall K1 K2 by K3, and in the bracket they have given us 2 by 3. Am I right? In the bracket they have given us 2 by 3. We have to calculate the overall activation energy. Overall activation energy in kilojoule per mole, and they have given 180, 80 and 50, K1, K2 and K3, somewhat they have given us. Now as usual, what I told you in the previous problem, we have to get overall activation energy. Overall activation energy. All right, this is the overall activation energy. Now see what we have to do. K1 and K2 are in the numerator and they are being multiplied, so EA1 plus EA2 we have to add. Then as it is in the denominator, so we have to subtract EA3, and overall they have given 2 by 3. Write it as it is. Afterwards we will deal with it. Now EA, how much they have given? 180 plus EA2. EA1 they have given 180. EA2 they have given 80 minus EA3. How much they have given? 50. Now this will be 2 by 3. Now this 2 by 3 I am writing here. Now 180 plus 80 is your 260. 260 minus 50 is 210. Right? 210. Now 370. 3 sevens are 21, 0. 3 sevens are 21 and 0. Now 2 into 70 is your 140 kilojoule per mole. See, this is very important problem, okay, very important model, very important problem from activation energy. Many students will leave it, what we have to do, what we did, just we have added EA1 and EA2 and we had subtracted EA3. Why? Because it is in denominator. Just substitute the values, they themselves have given, okay, they themselves have given the values. Now 2 by 3 they have given us. Here we didn't had any 1 by 2, 2 by 3, we don't have any multiplication, so we just approached in this manner. But here they have given 2 by 3. What we did, I just took it on the left side and I multiplied it. As soon as we multiply, we can cancel and ultimately we can get the answer in 2 steps, right? That's all. Hope you like the video. If you like the video, don't forget to hit the like button, share with your friends because sharing is caring, as well as hit the subscribe button because every day I'll be uploading a super cool video with amazing shortcut tricks, so that you do not miss. Hit the bell button also, okay? Do subscribe as well as like my video. Thank you. Thanks for watching.